Hello students, myself Amrita Dhar, Assistant Professor of Electrical Engineering Department of Greater Kolkata College of Engineering and Management, JIS Group. In this video, I will discuss about mechanics of train movement, adhesion and coefficient of adhesion, and characteristics and features of traction motors. These topics are included in Module 4 of the subject Utilization, Traction, Heating and Drives. Subject code is EE/S5/UTHD. Mechanism of train movement. Mechanism of train movement. Now first I draw a diagram. Now this area is 1, this area is 2, this area, I number this area as 3 and this area 4. Now what is 1? 1 is armature of traction motor. Area number 2 is pinion of motor. Number 3, gear wheel. And number 4 is the driving wheel. So this is the armature of the traction. This is the pinion of the motor, this is the gear wheel and this is the driving wheel. Okay, now this figure shows schematically the essential driving mechanism of an electric vehicle. The armature of the traction motor has a pinion meshed with gear wheel and driving wheel. This pinion is meshed with gear wheel on driving wheel. Now suppose the traction motor exerts a torque T which will be transmitted to driving wheel through the gear. The torque T is equals to F1 R1. F1 is the tractive effort and R1 is the radius of the pinion. Okay, radius of the pinion is R1. Now gamma is the gear ratio. Let gamma is the gear ratio. Now which is equals to speed of motor pinion in RPM by speed of the driving axle in RPM, which is equals to capital N1 by capital N2. Capital N1 is the speed of the motor pinion in RPM and N2 is the speed of the driving axle in RPM. Now if F is the tractive effort at the driving wheel and R is the radius, then F into R is equals to F1 tractive effort at the pinion, R is the radius of the pinion, and eta. Now what is eta? Eta is the efficiency of transmission. Efficiency of transmission of power from motor to driving axle. Now R is the radius of the gear wheel fixed to the axle. Now what is R? R is the radius of the gear wheel fixed to the axle. So therefore F is equals to F1 R eta by R. Suppose this is equation 1. From equation 1 we get this. Now this is now F1 R1 is equals to T. So I can write this equation as this equation. And what is F1 R1? F1 R1 is torque T R into eta by R into R1. Now gamma is equals to N1 by N2 and this is equals to R by R1. So T R by R1 is gamma eta by capital R. Coefficient of adhesion. Now from our previous discussions, it is clear that greater the torque exerted by the traction motor, greater is the tractive effort at the driving wheels. Now this relation holds good only up to certain extent, beyond which any increase in motor torque does not increase the tractive effort but causes driving wheel to slip. Now it has been observed that there is a maximum value of tractive effort at which driving wheels will not slip, and thus values depends upon the dead weight or adhesion weight over the driving wheels. That is, F is proportional to W. What is F? F is the tractive effort and what is W? W is the adhesion weight. Or we can write F is equals to mu A into W. Okay. Now if F is in Newton and W is in ton, then the equation can be written as F is equal to 1000 mu A into W into 9.81, where F is in Newton and W is in ton. Okay, now here this mu A is known as coefficient of adhesion. This is known as coefficient of adhesion. This means to haul a given train, there is a certain minimum weight of locomotive. Again, the maximum allowable weight on each driving axles is limited by the strength of the track bridge, etc. to between 15 and 30 tons. Now, if this value is known, the number of axles can be obtained. Now, with DC locomotives, since the DC motors are light and it is desirable to place the whole of the locomotive weight on driving wheel to obtain required tractive effort, whereas with AC locomotives, since the weight of electric equipment is higher, the required tractive effort can be obtained by placing only a portion of the weight on the driving wheels and supporting the rest on the trailing axles. Now, the value of coefficient of adhesion is affected by the speed of the train and the condition of the rails. The higher the speed, the smaller is the coefficient of adhesion. If the rails are wet and greasy, the coefficient of adhesion is much lower as compared to when they are dry and sandy. During starting, if the tractive effort varies, the maximum value of the tractive effort must be less than the product of adhesive weight and the coefficient of adhesion. This means the more uniform the tractive effort during starting and initial acceleration periods, the heavier will be the train which can be operated by locomotive of given adhesion weight. This criteria is of paramount importance, especially in case of goods train where the weight of the train usually approaches the maximum weight which can be handled by locomotive. And this is why the starting of traction motors either by series parallel method or by rheostatic method or by tap changing method is inferior to the method where applied voltage is smoothly and continuously varied, such as by means of grid control in vacuum tubes or by gate control in the case of silicon controlled rectifiers. Next is traction motors. Next is traction motors. Now, the motor for electric traction has to operate under conditions which are more arduous than those in most industrial application and a special type of motor known as traction motor. Now, the traction motor has been developed which incorporates some features. First feature is electrical feature. Under this category, first is high starting torque. Next is series speed torque characteristics. T is proportional to 1 by n. Third is simple speed controls. Fourth is possibility of dynamic or regenerative braking. Fifth one is better commutation. So these are the electrical features. Next one is mechanical features. Mechanical features. Under this category, first, light in weight. Traction motor should be light in weight and space requirement is small. Small space requirements. Next, totally enclosed especially if mounted beneath the locomotive. And last one is robust. It should be robust and should be able to withstand vibration. Okay, now none of the motors which have been developed satisfied all these requirements. So it has been found that the series and compound motors operate satisfactorily on DC system, AC series motor on single phase system and induction motor on 3-phase system. So we discuss one by one. First we discuss DC motors. We discuss about DC motors.
That's all from today's class. If you have any problem, please contact with me. My contact details is given on the first slide. Thank you.